All right, we're going to go ahead and get started, and we're doing today depreciation and appreciation, which is almost the same thing as sales tax and discount. So the formula that you learned yesterday is the same formula that you're going to learn today. So appreciation is an increase in value. And the formula looks like this: A equals P times 1 plus R to the T. P is your principal, or what you started with. R is your rate, just like we worked with yesterday. And the only difference is that today we're putting a power on it, and it would be time. And again, this A is what you want in the end. So your end value. Depreciation is a decrease in value. And the only difference in the formula is it's the minus. Same variables, same meaning. So yesterday we did sales tax, and that was the top formula, but we just didn't have a T, and discount was the bottom formula. So same formulas from yesterday, we're just putting power to it. That's it. All right, so on exercise 1, it says write the formula. The car depreciates, so it's going to be a minus formula. We have a rate of 5%, but how do we write that as a decimal? From yesterday, how do we write 5% as a decimal? Not 2 zeros, but just 0.05. You're okay. You're okay. You're okay. And then 3 years is going to be your time. Now, we don't know the start formula. I don't like this one because you don't have a start value. So we'll just put a P. It's going to be 1 minus. Our rate is 0.05. And we're doing it for 3 years. The next one is the same thing, except it says appreciates. That means we're going to use plus. It's going to increase. So A equals P, 1 plus. What's our rate as a decimal? 0.02. And how long are we doing this for? 15 years. That's it. Carbon-14 loses 35% of its radioactivity in 3,456 years. So it says loses. So are we using plus or minus? Minus. So A equals P times 1 minus. What's our rate? 0.35. And how long are we doing this? 3, 4, 5, 6. The next one says the stock gains 14% interest every year for 8 years. So gains is going to be the plus. What's our rate? 0.14. How long are we doing it? 8 years. That's it. So eventually what we're going to do is just keep putting it in our calculator. Okay, so we'll get everything in there and put it in our calculator. Sorry, y'all. Heather bought a car for $20,000 in 2010. Cars will depreciate. What does that mean? Decrease. Around 15% a year. How much is the car worth in 2030? So we're looking for how much it's worth. How much did it start with? How much did they buy the car for? $20,000. You said it depreciated, which means it decreased in value. So we're going to use our minus. What was our rate? 0.15. And then how long are we doing this? Not 10. Why 20? So we had 2030 was our finish year, but we started at 2010. So when I subtract those, I get 20. If you don't want to subtract them, you can put them up there just like this. So then you're going to get your calculator. And you're going to type this in. 20,000, 1 minus 0.15 to the, and you can type in the 2030 minus 2010. So you don't have to do the work. When you hit enter, what do you get? How much is the car worth? And 19 cents. That's it. It's the same thing we did yesterday. We just have a power. Jessica purchased a house for $120,000 in 2012. The house will appreciate over time at about 5% a year. How much will the house be worth in 2035? So I'm gonna start my formula. How much did we originally pay? 120,000. Is it 1 plus or 1 minus? Plus, because it's appreciate. What's my rate? 0.05. And how long are we doing it? How do I figure that out? There you go. And just put it in your calculator. 120,000, 1 plus 0.05 to the 2035 minus 2012. What do we get? Did I see it? We good? All right. If you don't know how to say it, 368,582. 85. $368,582.85. You don't have to say it specific. You can just call it the numbers. It's okay. Morgan bought a motorcycle for $15,000 and it will lose value over time. How much is it worth in the year 2025 if it depreciates at a rate of 18% per year? So A equals, how much did we originally buy it for? Make sure 15,000. Watch that zero on the end. 1 plus or 1 minus? Why is it minus? Depreciates or loses value. What's next? And then how long are we doing it? So how do we figure that out? What if they don't give us a year? What one are we going to put? We got to put one. You should always assume it's right now. So what year is it right now? Okay, so 2025 minus 2020. So again, if they don't put a year, just assume it's right now. 15,000, 1 minus 0.18 to the 2025 minus 2020. What do we get? Hmm? 5,561 and 10 cents. I rounded it to 10. If you give me 9, it's fine. Okay. Last one on this page. James invested in a stock that grew annually 8% every year. James bought the stock at $500. How much is it worth in 7 years? 7 years. So how much did he originally buy it for? 500. 1 plus or minus? Why is it plus? It grew, so we're adding. Percent? 0.08. And how long are we doing it? 7 years. Put that in your calculator. 500, 1 plus 0.08 to the 7. And we get 856.91. Any questions? Everybody okay? Not too bad, right? Something better thought to be. The only thing that's confusing is when they give you 2 different years or something like that. Okay. Next page. Suppose the value of a computer is given by the equation 700 times 0.915 to the x. Tell me what the original value of the computer was. 700. What percentage is the computer depreciating by? Yesterday, you talked about the multiplier and then the change of rate or rate of change, whatever you had. And I told you it was how far it was from 1, right? Okay, so this is the same thing. How far from 1? So you got to do 1 minus 0.915. What do we get? 0.085. Everybody good with that? But it asks for the percentage. So how do I do that? Move the decimal. And I get 8.5%. Everybody okay? So subtract it from 1 and then move your decimal. The Thompsons bought a $100,000 house in 2010 and it appreciated by 5% yearly. How much is it worth now? Okay. So how much did they pay for it in the beginning? 100,000. 1 plus or 1 minus? Plus, because it appreciated, so it grew. What's your percent? And then how long? Oh, the other one, 20, what? 2020 minus 2010. All right, clear this out. 100,000, 1 plus 0.05 to the 2020 minus 2010. What do we get? 162,889.46. That's it. Any questions? All right. The value of 2 loans is given by A of x equals 500 times 1.035 to the x, and B of x is 500 times 1.062 to the x. What is the principal amount or the original amount of the loan? 500. Remember that first number is always what we start with. What's the interest rate for each one? So let's look at A. This one is A right here. This one is B. So what's your interest? Remember inside, your interest rate is going to be whatever it is from 1 and then written as a percent. So how far is this from 1? This one. How far is it from 1? Remember, these are the easy ones. The hard ones are the ones that are less than 1. How much over 1 is this? How do I write that as a percent? Which gives me 3.5%. That's it. So what about B? How far is it over 1? 0.062. So that means your percent is 6.2. That's all it was looking for. How much more will loan B be worth after 10 years? Guys, this is more like an EOC question right here. So what do you have to do to be able to find the difference in the loan after 10 years? Absolutely. Figure out both of them and then subtract them. So we're going to start with the first one. We're going to figure out A. So we're going to put the A function in, 500 times 1.035, and we're doing it for 10 years. We get 705.30. Then we do B. B is right there above my calculator. 500, 1.062 to the 10. Then we get 912.46. And then Brianna, so we do what? Subtract 912.46 minus 705.30 gives us what? $207.16. That's it. All right, same thing as yesterday. On the original value, the increase or decrease, and then the rate of change, just like yesterday. So on the first one, what's your original value? 150. Is this an increase or a decrease? How do you know it's an increase? It's above 1. Okay, anything less than 1, between 0 and 1 is really what it should be, is a decrease. So this one's increase. And I don't want you to change it to a decimal. You're fine not putting a decimal in there. I mean, change it to a percentage. What's your rate of change? How far is this from 1.13? Just leave it like that and it's fine. Okay. That's it. Look at number 2. What's your original value for number 2? That's the box on the top. 2,500. Is this an increase or a decrease? Increase because it's over 1. And how much is it over 1? 0.085. Number 3, what's your original value? Increase or decrease? Decrease because it's less than 1. Your rate of change on this one, you got to tell me how far it is from 1. So you just do 1 minus 0.925. Because it's less than 1. And what do we get? 0.075. That's it. Look at number 6 since we're staring at it. Excuse me, y'all. What's your original value? Is this an increase or a decrease? Yeah, check this out. 3 divided by 2 is 1.5, right? So this is going to be an increase. Because again, this is the same thing as 70 times 1.5x. What's your rate of change? How much is it higher than 1? You can do 0.50, you can do 0.5, it doesn't matter. The bottom one has 3/4. 3/4 is 0.75. What's your original value? Is this an increase or a decrease? What's your rate of change? How far is it from 1? 0.25. Any questions? All right, let's do the last 4. Let's do number 5. What's your original value? 20,000. Is this an increase or decrease? And how much lower than 1 is it? Remember, we do 1 minus 0.92 and we get 0.08. Original value on number 8. Increase or decrease? Increase because it's over 1. Rate of change, how far over 1? 0.06. Number 4, original value. Increase or decrease? Rate of change, how far is 0.85 from 100? Not 25 bucks, 15. And then the last one, just to let you know, 5 over 4 is 1.25. So what's our original value? Increase or decrease? How far over 1? That's it. One more page, guys. It's easy to. All right, next now statements. Remember we did next nows with linears? So I'm gonna write one up here for just a second. So say we had this as a linear. We're not doing linears today, but I want to remind you what it was. We write it as next equals now. For linears, we're always adding and increasing. So we would add 6 or add your slope each time. And we started at our y-intercept. Oh, there, why yourself. Sorry, if I yielded. All right, during a certain period of time, about 70 otters had an annual growth rate of 18%. Write a y equals. So just what we were just doing. What's your original amount? 70 times, is it 1 plus or 1 minus? Plus, because it's growth. What's your rate? Not start at, to the x. All right, so your next now, this is how it changes. When we rewrite this equation, what did we call this yesterday? What did we call that number inside parentheses? The multiplier. Why do we call it the multiplier? Because it keeps multiplying and multiplying and multiplying. Linears are repeat addition. Add. Exponentials are repeat multiplication. Multiply. So instead of plus 6, we're going to multiply by what our multiplier is. 1.18. What was our beginning value? Start at 70. Nothing changes. The only difference is instead of add, it's going to be a multiply. That's your next now. We'll talk about C and D in a minute. I want to go ahead and write some more. A city of 100,000 is having pollution problems and is decreasing in size 1% annually. So how do I write a y equals? What did I start with? 100,000. 1 plus or minus? Minus. How do I write 1% as a decimal? .01. And then we're going to write it to the x. Next equals now. What operation are we using? What operation are we using? Multiplication. Remember, if I clean this up and I put in my 1 minus 0.01, what do I get? 0.99x. That 99 is my multiplier. So times 0.99. Start at what? 100,000. All right, your next now really doesn't help you that much. They just want you to learn how to write them. If we go back up to the other part, C, it says what was the population after 4 years? That's what we've done this whole time. So we write our formula. But now our year number is 4, or our time is 4. So 70 times 1.18 to the 4. And what did I get? That's it. All right, let's look at C on the next one. What was the population after 4 years? How do I do that formula? Y equals what? 100,000 times what? Point what? 99. And then how many years are we doing it for? 4. So we just plug that into our calculator. 100,000, 0.99 to the 4. We get 960.59, 60. All right, so now both part D's ask you about quadrupling and reducing. And so we have to use our table for that, okay? So let's start with D on number 2. What was our population to start with? What would be half of the population? 50,000. Okay, half the population is 50,000. We want to know how long it takes to get there. So what we do, put your function into y equals. If there's anything in there, just get rid of it. So 100,000 times 0.99 to the x. Go to your table, so second graph. And look for as close as you can get to 50,000. So we're in 70s, 60s, still going down. It's a long time, just to let y'all know. 58. Oh, there's 49,984. So about how long does it take? About 69 years. And again, that's exactly what your table is for. Now, when you get to math 3, you'll learn how to solve these and get the actual answer, but you're not going to do that for a while. All right, one more question up here. What does quadruple mean? 4. So we're going to take 70 and multiply it by 4 to get 280. So I'm going to put that function in and look at my table till when it gets to 280. So 70 times 1 plus 0.18 to the x. We're going to go to our table and we're looking for 280. Ooh. There's 70 and 82 and 97 and 115. Looking for 280. So where's it at? Right, in between 8 and 9 years, right? So about how many years? I would go with the higher one, about 9 years. So you're just looking at it. I think on your test it says like between 8 and 9. So wherever that value falls. Okay. All right, that's it. Your homework is right behind it. You need to listen carefully. It is not multiple choice. It is not multiple choice. I don't want you to do any of the D parts. So no D's. On number 5, no D or E. You go to the next one. That one's good. Good. Don't do part E on number 7. And then everything else should be okay. And then let's do this. Can I make it even shorter for you? Y'all okay with that? Okay. Let's just do the even. Is everybody okay with that? So that way you have a little less work to do. Okay. Zoomers, you got that? Just do the evens. So again, 2, A, B, and C. Don't do D. Do 4, A, B, and C. Don't do D. When you get to 6, you're actually doing all of those. It's not bad, I promise. 8 is normal. 10 is normal. On number 12, do not do B. And then 14 is like the one we did a minute ago. Okay. Do the best that you can. All right, I'm gonna stop share.